Welcome friends to my YouTube channel. Now in my last video I have discussed about second latent heat equation and the equilibrium condition between the two phases, and we took the example of liquid and saturated vapor. Now in this video I shall going to discuss a new topic which is called triple point. Okay, thermodynamics of triple point. Okay, so let's start. So our today's topic is the triple point. Now what is it? Now at first we have to draw a pressure temperature diagram. Pressure temperature diagram, and the diagram looks like this. This is the meeting point O. Okay, this is the solid, this is liquid, and this is vapor. Okay, say A, B, C. Now this point is called triple point, where all the three phases exist simultaneously without any change in their relative proportion, obviously at a fixed pressure and temperature. So we can easily conclude that it is the point where for a particular pressure and temperature all the three phases exist simultaneously. Okay, so it is the point where, kindly ignore the noise which is coming from outside because today is Saraswati Puja. Okay, so it is the point where for a particular pressure and temperature all the three phases exist simultaneously without any change here, without any change in their relative proportion. Okay, so this is the definition of triple point. So at a particular pressure and temperature all the three phases exist simultaneously without any change in their relative proportion. So let us explain this matter. Okay, now whenever there is a equilibrium between any two phases, we know that there is a transfer of energy, and in case of a first order transition this transfer of energy is governed by first latent heat equation or Clausius-Clapeyron equation. Okay, so phase transition involves the transfer of energy. Okay, so equilibrium between any two phases, equilibrium between any two phases means there is a transfer of energy. Okay, there is a transfer of energy, and for first order phase transition it is governed by, for first order phase transition, it is governed by Clausius-Clapeyron equation. Okay, so for first order phase transition the transfer of energy is governed by Clausius-Clapeyron equation, and for second order phase transition it is governed by Ehrenfest equation. Okay, so let us explain this matter. Okay, now if you look back into the picture, then OA represents the equilibrium line between solid and liquid. Okay, what does the OA represents? OA represents the equilibrium line between solid and liquid. So that means in the left hand side of OA the matter exists in solid state, and in right hand side of the line the matter exists in liquid state. Okay, you already know it that OA represents the equilibrium line between solid and liquid. That means in the left hand side of OA the matter exists in solid state, and in right hand side it exists in liquid state. And what will be the Clausius-Clapeyron equation in this case? We can write it LF, latent heat of fusion, divided by T into volume of liquid minus volume of solid. Okay, where LF represents the latent heat of fusion. Okay, so LF represents the latent heat of fusion. Okay, and this is known as the fusion curve. Okay, and this is known as the fusion curve or fusion line. Fusion line. Okay, so OA represents the fusion line, and in this case dP dt equals to LF, latent heat of fusion, by T into VL minus Vs, volume of liquid minus volume of solid. Now if you look back into the line OB, then this line represents the equilibrium condition between liquid and vapor. That means in upward direction of OB, in this portion the matter exists in liquid state, and below OB line the matter exists in vapor state. Okay, so this is known as vaporization curve. OB is clearly called vaporization curve. OB represents the vaporization curve. Okay, so in this case what will be the Clausius-Clapeyron equation? That is latent heat of vaporization, LV by T, this Vg minus Vl, volume of gas minus volume of liquid. Okay, so this represents the vaporization line. Now if you consider the line OC, the last one, then what would happen in this case? So if you just go back to the line OC, so clearly you can see that in this portion the matter exists in solid state, and this portion it exists in vapor state. So that means it represents the equilibrium condition between solid and vapor, and that's why this is called what? Sublimation line or sublimation curve. This is known as the sublimation curve. And what will be the Clausius-Clapeyron equation in this case? This is latent heat of sublimation by T into here V, vapor, volume of gas minus volume of solid. Okay, thus we see that O is the common point where all the three phases exist simultaneously for a particular pressure and temperature, and this is called the triple point. Okay, so O is called the triple point. Okay, and if we took the common example ice water vapor, then the equilibrium temperature, that is if we took the example of ice, water and vapor, then what will be the equilibrium temperature? The equilibrium temperature almost 273.16 Kelvin. Okay, for ice water vapor mixture the equilibrium temperature will be this 273.16 Kelvin, and the equilibrium what, that is 4.5 millimeter of mercury. This is the equilibrium pressure. Okay, so if we took the common example, that is ice, water and vapor, the equilibrium temperature will be 273.16 Kelvin and pressure will be 4.5 millimeter of mercury. So remember it. Okay, so let us discuss a special case which all of you must have to know. Okay, so let us discuss. Now let us suppose that these 3 points do not mix at a particular point. Okay, they don't meet at a particular point. Okay, they, that means this is the area. Okay, suppose they don't meet a particular point. Okay, but they are confined within the triangle, that is the shaded region ABC. Okay, suppose let us assume that these 3 points don't meet at a particular point and they cover this portion, that is within the shaded portion. Then what happens? This is not possible. Why? Because if it happens, then according to ice line, the matter must be in solid state within the shaded region. According to vaporization curve, the matter must be in liquid state in this portion, and according to sublimation curve, the matter must be in vapor state. Okay, in this region. So this is not possible. So they must meet at a particular point. Okay, but suppose if they do not mix at a particular point, but they confined within the shaded region, then what happens? According to the ice line, the matter must exist in solid state within this entire region. According to the vaporization line, the matter must exist in liquid state within the entire shaded region. And according to sublimation line, the matter must exist in vapor state within the entire region. But this is not possible simultaneously. Simultaneously, this is not possible. So they must meet at a particular point. Okay. So 3 lines must meet at a particular point. Okay, this shaded region and this type of form is not possible. It is not possible that for a particular line the entire substance can exist simultaneously in different forms within a particular region. So they must meet a particular point. Okay, so this is what about triple point. Now let us do 2 problems. The first problem is that let us do 2 problems. Here given that P, the pressure is given in the form of this f of v into T, where f of v is a function of v. Okay, and we have to show that entropy increases with volume. We have to show this entropy increases with volume. Okay, now from this relation what we can write? Del P del T volume constant, this means f of v, and f of v means P upon T. Okay, so this we can write. Now from Maxwell's relation what we can write? Del P del T volume constant, this equals to del S del V temperature constant. So this we can also write P by T. So this P by T is a positive quantity, that means entropy increases with volume. So it is a simple and interesting problem. From this line we can write del P del T volume constant equal to f of v P by T, and del P del T volume constant means del S del V temperature constant. So this can also be equal to P by T, and since P by T is a positive quantity, S increases with V. Okay, so this is a simple and interesting problem. Okay, now we shall do another problem. In case of a black body radiation, we have to show that the pressure only depends on temperature. Okay, so for black body radiation, for black body, P only depends on temperature. Okay, for black body pressure only depends on temperature. Now black body radiation we will learn in radiation chapter later. Okay, so till today just you know it that for black body radiation Gibbs potential is 0. You just know it. I will tell these matters in radiation chapter. clearly why this happens. Okay, but simply you know that for black body radiation Gibbs potential is 0. Okay, so what we can write, that means U plus PV minus TS will be 0. So what will, if we do differentiation, then this, okay, minus TdS minus S dt, this equals to 0. So du plus pdv means TdS. So from which we can write VdP equal to S dt. And from here we can write dP, this equals to S by V into dt. Just give it a name, equation 1. Okay, from which we get VdP equal to S dt. So what will be dP? S by V dt. Now suppose let you consider pressure as a function of volume and temperature. So what happens? What will be my dP? My dP will be del P del V temperature constant dV plus del P del T volume constant dt. Now if you compare these two equations, then you can clearly see that this is dt, this is dt. So del P del T equal to this, but here there is no del V del T term. So that means comparing, you can easily say del P del V temperature constant is 0. Okay, so from this equation you can easily conclude that for black body radiation pressure only depends on temperature. So this term is 0. That means if pressure is only a function of temperature, then its derivative with respect to volume will be 0. So the pressure must be a function of temperature. Okay, so pressure must be a function of temperature and depends only on T. So if pressure is a function of temperature only, then the derivative with respect to V will be always 0. So for black body radiation pressure only depends on T. So dear guys, if you don't subscribe my channel, then kindly subscribe to get latest videos on physics. Okay, thank you.